In this video, you will learn about parallel and perpendicular lines. The lesson objectives are to learn the relationship between the gradients of parallel lines and also to learn the relationship between the gradients of perpendicular lines. Aside from that, we also learn how to find the equations of parallel and perpendicular lines. It is important that you already know how to find the gradient of a straight line. Also, you should know how to find the equation of a straight line. These concepts are discussed in my previous videos. Two lines are parallel if they have the same gradient. For instance, if we have these two lines with gradients M1 and M2, then these two lines are parallel if their gradients are the same. So M1 equal to M2. Also, two lines are said to be perpendicular if their gradients are negative reciprocal of one another. So if, say, this is line with gradient M1 and this is a line with gradient M2, then the gradient of M2 should be equal to the negative reciprocal of M1, or M1 should be equal to the negative reciprocal of M2. In other words, the product of the two gradients M1 times M2 should be equal to -1. Example 1. Line L has the gradient 5/3. Find the gradient of any line which is parallel to L. B. Perpendicular to L. So for A, two lines are said to be parallel if they have the same gradient. So if the gradient of the line parallel to L is M2, then it must be 5/3. B. Two lines are said to be perpendicular if the gradient of one is the negative reciprocal of the other. So if M2 is the gradient of the line which is perpendicular to L, then its gradient must be negative reciprocal of the gradient of line L. So -3/5. Or in other words, the product of the two gradients must be equal to -1. So 5/3 times M2 should be equal to -1. This implies that M2 is equal to -1 divided by 5/3. This means that M2 is equal to -1 times 3/5. This implies M2 is equal to -3/5. Example 2. Find the equation of the line which is parallel to the line y equal to 3/2x minus 1 and passes through the point -2, -8. To find the equation of that line, we need its gradient. So gradient of the line will be equal to 3/2. Since it is parallel to this line, then they have the same gradient. So it means that its gradient is 3/2. Using the point -2, -8 means that y is equal to 3/2x plus c. So here our x is -2 and our y is -8. This implies that -8 is equal to 3/2 times -2 plus c. So -8 is equal to -3 plus c. Making c the subject means that -8 plus 3 must be equal to c. Therefore, c is equal to -5. It means that the line which is parallel to line y equal to 3/2x minus 1 is y equal to 3/2x minus 5. Example 3. Find in the general form the equation of the line which is perpendicular to the line y equal to 2x plus 1 and passes through 4, 1. In this equation, the gradient of the line is 2. Let M1 be the gradient of the line y equal to 2x plus 1, which is 2. Therefore, the gradient of the line which is perpendicular to it, M2, is equal to the negative reciprocal, which is -1/2. This implies that the perpendicular line is going to be in the form y equal to -1/2x plus c. Using the point 4, 1 implies that x is 4 and y is 1. Therefore, 1 is equal to -1/2 times 4 plus c. This implies that 1 is equal to -2 plus c. This implies that 1 plus 2 is equal to c. Therefore, c is equal to 3. Hence, the equation of the line which is perpendicular to y equal to 2x plus 1 is y equal to -1/2x plus 3. However, the question says we should write in the general form. So the general form of the equation of a straight line is ax plus by plus d equal to 0, where a, b, and d are integers. So to do away with this, the fraction, we have to multiply through by 2. This implies that 2y is equal to -x plus 6. This implies that x plus 2y minus 6 equal to 0. And this equation is in the general form. Example 4. Find in the general form the equation of the line which is parallel to the line 2x minus 3y equal to 10. First, we have to know the gradient of this line 2x minus 3y equal to 10. And to know the gradient, we have to rearrange it in the gradient intercept form, which is y equal to mx plus c. In this form, we can tell the gradient of the line. So we rearrange this equation in the gradient intercept form, and this becomes -3y equal to -2x plus 10. Dividing through by -3 implies that y equal to -2x over -3 plus 10 over -3. This implies that y equal to negative cancels negative, so it becomes 2 over 3x minus 10 over 3. In this form, we're able to tell that the gradient of the line is 2 over 3. So m1 is 2 over 3. This means that the gradient of the line parallel to 2x minus 3y equal to 10 is also 2 over 3. Since the two lines are parallel, they must have the same gradient. So m2 is also 2 over 3. This implies that the line which is parallel 2x minus 3y equal to 10 should be in the form y equal to 2 over 3x plus c. Using the point 3, -4 implies that -4 is equal to 2 over 3 times 3 plus c. This implies that -4 is equal to 2 plus c. Therefore, c is equal to -4 minus 2, which is equal to -6. This implies that the equation of the line is y equal to 2 over 3x minus 6. But since the equation says we should write in the general form of the equation of a straight line is in the form ax plus by plus d equal to 0. So we must do away with this denominator by multiplying through by 3. So this implies that 3y is equal to 2x minus 18. Therefore, the equation of the line in the general form is -2x plus 3y plus 18 equal to 0. The trapezium PQRS has vertices P, Q, R, and S. We are asked to show that PQ is parallel to SR. We have the point P, -5, -2, and Q, 3, 4. So let's say this is X1, Y1, X2, Y2. This implies that the gradient of PQ is going to be 4 minus -2 all over 3 minus -5. This is equal to 6 over 8, which can be simplified to 3 out of 4. Now, let's go on to find the gradient of SR. S has the coordinates -2, -6, and R has the coordinates 10, 3. So it means that the gradient of SR is going to be 3 minus -6 all over 10 minus -2. This is 9 out of 12 and can be simplified to 3 out of 4. So since the gradient of PQ is the same as the gradient of SR, which is 3 out of 4, it means that the two lines are parallel. B, we are asked to show that PQ is perpendicular to PS. So P has coordinates -5, -2, and S has coordinates -2, -6. Gradient of PS is equal to -6 minus -2 all over -2 minus -5. Negative will change to positive. So this is equal to -6 plus 2 all over -2 plus 5, which is equal to -4 all over 3. Remember, we've already found the gradient of PQ to be 3 out of 4. So when we compare the gradients of PQ and PS, we notice that one is the negative reciprocal of the other. Hence, the two lines are perpendicular, or the product of the two gradients, 3 out of 4 times -4 out of 3 is equal to -1. This means that the two lines are perpendicular.